All right, so we are going to quickly go through the Unit 11 Day 5 warm-up. Right, the good thing is you got the green boxes there indicating whether or not you got it right, but if you just want to see some process for these problems. For the first one, right, recognize what kind of shape you're dealing with. I know that this is a parallelogram. Our opposite sides are parallel. My base is going to be 14, and perpendicular to that base, my height is 12. When it's a parallelogram, all you are just doing is base times height, not changing anything up. 168. If I had units, that's where I would use units squared, right? So if it were inches or feet or miles, right, I would say inches squared or feet squared or miles squared, right? Really doesn't matter in this case because I'm not giving you any of them. So it's okay. 168. For the next one, right, and I talked about this last class, being able to figure out which sides you actually need, right? In this case, I don't need 17 and I don't need 10. Why? They're not perpendicular to anything, right? So I see that my base is going to be 21 and my height perpendicular to that is 8. So I have 21 times 8. Now, because we're dealing with a triangle, right, it's not just base times height, but instead it's base times height divided by 2, right? So I'm doing 21 times 8 divided by 2. That's going to get me 84, right? And again, units squared, you don't need to write in units. I'm totally fine with that. For problem 3, again, still dealing with a parallelogram. Don't just do 30 times 20, right? 30 and 20 are not perpendicular to each other. You just have 30 times 17, right? Your base times your height, that should get you 510. So when it is a parallelogram, just base times height. When it is a triangle, you need to make sure that you are dividing by 2. All right, now I'm going to kind of go through the next two pretty quick. Squares, right? All of your sides are the same. Can I solve this the same way as I solve all the other ones? Sure. Base times height. Your base and your height are both 15. But with a square, easiest way to think about it is just side squared. So I just have 15 squared. That is how I'm going to find the area of any square. That's going to get me 225 units squared, and I'm all good there. Trapezoids. Trapezoids are a little unique. Right, and I talked about it in class. You're finding the average length of your base and then multiplying it by your height. But we don't necessarily write our formula like that. Right, we multiply the height times the sum of our bases. In this case, 6 plus 8. I don't know why I just put 8. Your height is obviously 4. That's the distance between your two bases. And then you're dividing it by 2. So I should be doing height times base plus base divided by 2. This should get you 28. And hey, we have units, so we can write feet squared. For the last two, we're looking at a kite and a rhombus. For our kite here, I have one of the diagonals is 6, and the other diagonal, even though it's not drawn in the picture, we're still given that distance from here to here to here is 14. So I have diagonal 1, which maybe we'll say is 14, times diagonal 2, and don't just leave it like that, you're dividing by 2. Sorry, I just got a text and needed to look at it. This should get you 42, and then we have units, inches squared. All right, and then lastly, right, and again, I don't even know how many I have of you at this point because you have the green boxes on Class Kick, so might not even be watching. But diagonal 1 times diagonal 2. This is very wrong. Don't just put 40 times 30 divided by 2. The entire length of your diagonal is not 40, and the entire length of that diagonal is not 30. 40, 40, that's going to be 80 times, that's 30, 60 divided by 2. That's going to get me 2,000 400 meters squared. And if I got units, I might as well use them. If I don't, it's okay either way. You should now be moving on to the video notes that are posted to Schoology.